just as people are taking their seats, I know we've all had a nice short coffee break there, but we're back. And it's my very great pleasure to introduce what is now the 8th session of the conference, the ISAE 2020, and it's on motivation, cognition and emotion. I'm Lucy Asher and I'm a professor at Newcastle University and have done some work in this area, so hopefully I can guide us through this session this afternoon. I understand first up our speaker is going to be online and I think is maybe going to be a video, but the presentation is by Annelise Dauphine-Moreau. Hopefully I've pronounced that not too horribly, and we're looking at investigating intention in non-human animals.
Hi, could you hear me? Hello?
Hello, I think anytime you're ready, I think we've got your slides up and we can see you're on the screen. So anytime you're ready, Annelise.
Okay, so perfect. So good afternoon. I'm Annelise Dauphine-Moreau. I'm a PhD student. And I will present you my work on how to consider non-human animal intention with an interdisciplinary approach. To begin this work, we explored how intentions are studied in scientific literature. To do that, we created an exhaustive corpus based on the keyword intent and on all the disciplines involved in the study of intentions. In this first corpus, we found only 0.1% of paper on non-human animals' intentions. We explain these little numbers of paper by two main reasons. The first one is the use of the specific ethological terms by ethologists to study intention, and the other is the self-censorship hypothesis, that is, to be able to publish in scientific review, researcher doesn't use the term intentions. To go around these limitations, we recreate a new corpus, but this time focused on the field agricultural and biological science. And we focus on the 4 past years. We analyzed this corpus with author keywords called co-occurrence network, and we identified non-human specific terms used to study intention. We recreate a new corpus based on these new terms in order to explore how intention is studied in non-human animals. We focused on papers that study really non-human animals, and we analyzed it with an author keyword co-occurrence network. We found 10 approaches, scientific approaches of intention in non-human animals. So here you can see in the screen the obtained co-occurrence network. Just to explain a little, so each node represents one author keyword found in our corpus, and each edge between two keywords is the co-occurrence on same paper of the two keywords. So in other words, here we have one cluster that corresponds to one scientific approach of intention. And here, for example, researchers that studying intention through the imitation also work on teaching to use tradition, culture, etc. So what is really interesting in our co-occurrence network is that for each of the 10 approaches, we found that they are related to human by two different ways. The first one is we study current cognitive abilities on other species to try to understand, to find the origin of the same cognitive abilities on human. And the other way to be related to human is we define what is an intention based on what we know of human intention, and we try to look if we found this kind of intention in other species. So what could be a non-human intention? And so how to access something that we can't directly conceive. In other words, if other kind of intention than human intention exists, we can't directly designed a protocol to measure it. We have to find a way to access it. To explore this question, we designed interdisciplinary workshops to develop conceptual and methodological proposals. We decided to create this interdisciplinary workshop because we want to work on a theoretical framework of ethology, because as we are working on generical epistemology, we did the hypothesis that the current scientific limitation of the study of non-human intention are due to the current limitation of our theoretical framework. So, to explore that, we created an interdisciplinary specific context that involves ethology, logically because it's our discipline of interest, but also we involve psychologists because we know that ethology and psychology share a broad conceptual and methodological framework. And we also invited scientists from design and management science because these two disciplines are used to work with the concept of intentions, but also to work with other kind of knowledge than their own scientific knowledge. We, at the end, we organized 3 independent workshops with a total of 26 participants. Each workshop was designed around 3 sequences. The first time was an individual disciplinary time on which each researcher had to identify concepts, methods, and questioning for all the 10 approaches previously identified. At the end of this time, we obtained the 10 approaches completed by all the knowledge of our participants. Then we put the researcher in groups. Each group was composed of 3 researchers, 1 of each kind of disciplines. And each group had to pick up 3 of the 10 approaches of the intention in non-humans. Then each group had to identify a scientific hypothesis to explore intention, knowing these 3 approaches. When the hypotheses were identified, each group designed protocol to investigate this hypothesis. At the end of these workshops, we obtained a lot of data, and I will present you the first interpretation of this data. So how I explained a little before, question is how we can access other kind of intentions than human intention. To do that, we had to delimit one common base of what is intention, but sufficiently sensitive, open, to be able to identify other kind of intention. So here you have a mind map of our first interpretation of this data, and I will just show you some part of the results. So, for example, with our workshop, we identify some prerequisites to be able to have intentions. We also identify here when intentions are involving during the cognitive processes. And this result is really interesting for us because depending on which disciplines and which approach we used to work on intention, we will find intention in different moments of the cognitive process. To us, this result is a clue to work with intention as a complex object, not a too restrictive definition of intention. Other kind of results that we obtain is how we can observe and measure intention. And that is really interesting here is that we show that to be able to access intention, we have to work on the transformation that we link to the way to the fact to have intention. In other words, to have intention, individuals have to be put in relationship, and we observe this effect. We also measure intention by the transforming effect that they have. Finally, we identify another kind of results, another kind of effect, that is that when we consider that others have intention, we have modification of our own behavior. Based on that, we propose some guidelines to be able to explore intentions. So really briefly here, our main result is that intention can't be byproducts of other scientific research. In other words, we can work on high cognitive processes without able to access to see intention. So we have to really develop very specific protocol to be able to access and to assess intention. And I briefly explained before, we also found that considering intention have an impact on the observators. So here we identify some kind of effect of this consideration of intention. And we also find that there an effect between in the relationship between the animal observed and the observator. So we think that the consideration of intention has an impact as a loop effect between observers and animal observed. So in brief, during these 2 years, we show that there are still few studies on non-human intentions. And these studies are mainly based on anthropocentric approaches. To go around these limitations, we propose to consider intention as a complex object in an interdisciplinary approach. When we consider intention as an interdisciplinary object and complex object, we show that we have to consider intention in relationship, and we have to measure it by the transforming effect that they have. To explore these two main results, we plan for the next year to develop experimental approaches on two different ways. The first one, we plan to look what is the kind of impact that considering intention. In other words, when scientists consider that their animals have intention, which kind of science these scientists do. And the other part is we plan to develop for 3 given species specific protocols and ethodrums to assess their intentions. So I want to thank my team project to their support and thank you for your attentions.
Thank you very much for a lovely talk. So we'll take questions now. I have been asked if people can make sure they introduce themselves and also stand up, because that allows the speaker to see and people online. So do we have any questions?
Bjørn Falkman, University of Copenhagen. Thank you for a nice talk. I was just wondering, I mean, if you have a concept which is based on humans, I mean, we are the ones creating the concept. How can they then not be anthropocentric? If you're trying to study something which is out with of our experiences or out with our concepts, then would you need a new word for that or something else?
Thank you for the question. It's really interesting. It's not a new word. It's maybe more another way to say that it's how how can I say that? If I define too restrictively my concept of intentions, I only work on what we know about intention. So it's not to create a new concept to be another word, but it's more like be more how I can say that. I'm sorry. Yeah, it's more like serendipity in French. I don't know it's the term in English, but to be sufficiently open to do the hypothesis that we are not able to assess directly intention. So in the current scientific literature, we are more like, we don't find this kind of intention in species, so species don't have intention. But my proposition is more, maybe we can do the hypothesis that we are not really able to access other kind of intention. So what is the impact to do that in our way to work on a scientific process? So for example, we can just have the same protocol, but another kind of interpretation of the data.
Thank you very much. That was a really interesting talk and really complex problem. So we'll leave it there if that's all right. And people feel free to get in touch with Anne-Lisa if they have any more questions. So next up we have Jan Langbein, who will be giving us a talk about goats and looking at whether they read 2D images of unfamiliar and familiar conspecifics. We hope there are slides.
Screen is black.
Yeah.
Microphone works at least. Okay.
Can you freestyle?
Should I take the microphone and come down? Yeah. Okay. 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 My name is Jan Langbein. I'm from the Department of Behavioral Physiology at the Institute of Farm Animal Research Institute of Farm Animal Biology in Donnersdorf, Germany. And here you can see the title of my talk: How do goats read 2D images of familiar and unfamiliar conspecifics? So, as you all know, individual recognition of conspecifics is a cornerstone for complex social behavior in many different taxa of social living species. And there are different approaches to study individual recognition of conspecifics, which I've put you on the slide. One is to work with real animals in tests to discriminate animals. And the other one is, or might be, to use photos of conspecifics in such discrimination tests. And both approaches have pros and cons. So for example, if you use live animals, you have more natural situation, and which includes social aspects beside others. But if you use photos of conspecifics and you show it on a computer, you can generate higher data collection efficiency, and you can more standardize the stimulus presentation. Okay, there are many different studies who has demonstrated the ability to discriminate pictures of conspecifics in many different taxa from insects to non-human primates, and there is a very comprehensive review study published already in 2000. Nowadays, image presentation mostly is realized by using computer screen. However, warning, sometimes results or positive results of those discrimination tests are a bit too optimistic, I guess, because discrimination of pictures of conspecific does not mean individual recognition. There are three stages have been defined of image processing in animals in a very fundamental work published in 2010. And these three stages are independence first, which means the images are processed independently of their context as visual stimuli only. And the second stage is confusion. That means the images are confused with the real objects, which are shown in the image. And only the third stage, called equivalence, gives you some indications that the images are read as representations of conspecifics, of real objects, or whatever you show. And only if you can found evidence that in such tasks this third level is reached, then you get evidence for individual recognition. And for my opinion, so far we have clear evidence of individual recognition according to this three stages. In farm animals, it's mostly in sheep. There's well-known studies from Kendrick, and in cattle, many different studies from Marie Coulon in France. So the aim of our study was to investigate if goats understand the referential relationship between photos of conspecifics and real individuals. To run this study, we used an automated learning device, which we have developed in our institute. This device is integrated in the home pin of the animals, meaning it's available to the animals 24 hours, 7 days a week. And that means the goats have unlimited visits to the device and unlimited number of trials at the device. So we present our pictures as 4-choice discrimination tasks, and we use drinking water as reward when the animals choose the rewarded stimulus in the picture set. So I have 2 little videos for you to show how it looks in the barn. First video, please. So here you can see the barn for about 12 animals, and this here is a compartment. No, it doesn't work. The compartment with a learning device, and the next video, please. And when a goat entered the device, it sees a screen. It's a real touch screen. And we present this 4 different pictures of 4 different goats on the screen. And by touching the touchscreen with its nose, the goat can make its choice. So our experimental approach goes like this. We work with 2 groups, Group A and Group B, 12 dwarf goats, kids each in every group. The groups were unfamiliar to each other, and the goats were housed in structured pens with straw bedding, concentrate twice daily, hay ad libitum. And under these conditions, we first shape the goats to the learning device, so they learn step by step how to handle the learning device. And at the end, we train them at 2 first picture sets. The first is black abstract symbols, and the second is 4 different portrait photos of sheep. And at the end of this training, all 24 goats are well habituated to the learning device and know what to do to get the drinking water at the device. So our test setup, we offered identical test sets or the picture sets for both groups, and we used photos of new groups, photos of new animals in each test. In the first test, portrait photos. In the second test, profile photos, and in the third test, photos of the body without the head. And the tasks were designed as follows. In these first 3 tasks, we used one picture of an animal from Group A as a rewarded stimulus, and 3 pictures from animals from Group B as unrewarded distractors. And so this is for the first 3 tasks, and then we run a reversal test at the end as test number 4. And here we reverse the principle from the first 3 tasks. We used one picture of an animal from group B as rewarded stimulus, plus 3 pictures from animals from group A as unrewarded destructors. And each of these tests run over 7 days, 1 day pre-test, where all choices at the device were rewarded equally to check out for spontaneous preferences for single pictures in the sets, and following by 6 days of discrimination training. So we formulated different hypotheses to investigate if goats read the images of representations of real objects. The first was we expected, in case they take the photos of conspecifics as referential symbols, we expected spontaneous preference for S plus in group A in the pre-test of test 1 to test 3, as has been shown in studies on non-human primates and in cattle. Second hypothesis was we expected faster learning of X plus in group A in the first 3 tasks. And there are studies who have shown this, exactly this. And faster learning of S plus, which is a familiar picture for the animals in group B in the reversal test. So by this, I would like to come to the results. Here you can see the results from the pre-test in the first 3 tests. The letters above the bars indicate difference between the 2 groups, group A in purple and group B in yellow, and between the different tests, here, the first 3 tests. So what we see is, in contrary to our expectation, we did not find a clear preference for the later rewarded S plus by the animals of group A, as in this first 3 tasks, the later rewarded stimulus was the picture of a familiar animal from their group. And moreover, we did not find any differences in the preference between the 2 groups in this first 3 tasks. There were different preferences, but uniformly for both, or identical in both groups. And here you see the results from the reversal test, test number 4, more or less the same results. Here we expected preference for the later rewarded stimulus, stimulus number 1, by the animals of group B, but we didn't find this. And again, no clear differences between the groups for all 4 different pictures. So the next slide shows the learning curves across the 6 days of discrimination learning. Again, on the first view, no differences between the 2 groups. The learning curves seems equally steep in both groups in all 3 tasks. It shows us that the animals easily learned the discrimination task. They reached the learning criterion, which is here for this curve, 46%, within 2 to 3 days. And if we look at the reversal test, we see quite the same, no difference between the groups. But what is striking here is that we see lower learning performance over the first 3 days. So if you compare this with the level of positive choice they reach in the first 3 days is quite lower as in the first 3 tasks. If we go to another criteria for learning performance, which is the number of trials the animals really needed to reach the learning criterion, we see again no difference between the groups in the first 3 tasks. Yeah, okay. And they use continuously between 100 and 180 trials to reach the learning criterion. But we see a different picture in the reversal task. Here we see a tremendous increase in trials they needed to reach the learning criterion. No difference between the groups, but more than double the number of trials to reach the criterion, which was quite surprising. So to summarize, no clear preference for S plus in group A in the first 3 tests or group B in the test 4. No difference in image preference between the groups in these first 3 tests. No faster learning in test 1 to 3 in group A. Both groups learn at the same speed and they needed the same number of tries to reach the learning criterion. And the other way around, no faster learning of S plus in the reversal test by the animals in group B. So conclusions. At the first view, it looks like the goats did not read the photos as referential signals from the results in test 1 to test 3, neither due to preference in the pre-test nor to difference in the learning performance between the groups. So it seems the goats process the images independently of their content, just as visual stimuli, at least from the results from the first 3 tests. But if we look at the results in the reversal test, then we get a clear indication that the animal established the categories familiar and unfamiliar across the first 3 tests, because otherwise we would expect it's the same low number of trials in the reversal test, in the first test. As the animals needed twice the number of trials in this test, we got an indication that they were confused by the reversal of the previously learned concept and first have to overcome this confusion before they can really start to learn the new contingency in this first test. Next step will be transfer tests to strengthen these preliminary results. And by this, I say thank you and happy to answer your questions.
Okay, do we have any questions? So I've got one here at front, Hanno.
Hanno Wirbel, University of Bern. Thanks for an exciting talk. And I'm just curious to know whether anybody has ever tested whether animals that learn conspecifics from photographs, from pictures, how they would respond to the real animals if they were confronted with them, so that they actually discriminate between animals. They learn to know certain animals. So they know some and some they don't know, and then they confronted with familiar and with unfamiliar animals based on the pictures and whether they would respond differently to these animals.
Yeah, well, I'm not sure what you mean by how do they react. So, well, you can design a test, but you first train them on this discrimination of pictures, and then you confront them with real animals.
Yes.
Familiar or unfamiliar. Yeah, okay, but
no,
will they approach the animal?
Familiar from the picture.
Yeah.
I'm just wondering if they had gotten to know certain animals from pictures, whether they, I mean, if you could show that they recognize them when they see them in reality, then that would probably be the acid test of recognition.
Totally agree. I have no idea how to design the test, but yeah, it would be nice. Maybe they approach a familiar animal faster or stay away from an unfamiliar. Yeah, we can think about that. Yeah.
Excellent. I'm going to take one more question if it's quick. So at the back there, sorry for everyone else.
Hi, so it's Jenny Weller from AFBI. I was just wondering if you found that water was a strong enough, drinking water, sorry, was a strong enough motivator for the goats to actually put the effort into learning.
Yeah, that's a question I expected first, because if I mentioned that we use drinking water as a reward, normally there's a question, wow, are they restricted of water consumption? In former times, we used feed as a reward, special food for them. But with our very open design, they can use it day and night, every day. If you use food or something like that, when they get an idea about which is a rewarded symbol, they get fed within days because they take out food as much as they can. With water, for us, it's a perfect reward. It's an essential resource. They need it all the time, but they never overuse it. And the critical thing is when we train or shape the animals to the device, we have to be very careful that we do not lose an animal. And we analyze the data, how they act at the device every day once. And so we find out if there are animals who are not smart enough to interact with the device, and we take out these animals immediately. So
thank you very much. Right, so we are sticking with goats because goats are obviously the optimal animal for motivation, cognition and emotion research. And now we're moving on to Marianne Mason's talk, which is can goats recognize humans cross-modally?
Hello. My name is Marion Mason and I'm a PhD student at the University of Roehampton. I will be discussing my research into whether goats can combine visual and vocal cues to recognize humans cross-modally, but we'll also be discussing one further project I run as part of my PhD research. So in evolutionary terms, recognition forms a foundation for complex social behavior, allowing organisms to discriminate among social partners and tailor their behaviors accordingly. Through repeated interactions between humans and livestock, dyadic social relationships can develop, allowing participants to recall outcomes of previous interactions and use these to anticipate the other party's future behavior. Results of human-animal relationship studies support a history of aversive and rewarding stimuli as being significant as shaping behavior towards individual humans. Cross-modal recognition refers to the brain's capacity to combine cues in two sensory modalities to discriminate objects, for example, through combining how an object looks to what sound it makes. This is thought to be especially useful when cues in one modality are either attenuated or unavailable. For example, it can be particularly hard to see in a dark environment, so we may say shift our reliance from visual cues to tactile or auditory cues instead. Cats, dogs, and horses can combine visual and vocal cues to recognize familiar people, but whether complex recognition of humans and livestock have been little tested, although livestock have been how well livestock distinguish between humans collect whether they can attribute positive and negative experiences to individuals, but little is known about complex recognition of humans and livestock, including cross-modal recognition. A former study conducted at the same study site as where I did my research presented one goat, a subject with a pair of goats, and a speaker placed between them. When the subject was presented with a pen mate and a random herd member, the call for one of the goats were able to match call to the goat and turn towards them accordingly. This suggested that goats can cross-modally recognize individuals or goats, cross-modally recognize goats using visual and vocal cues. Goats are also sensitive to a variety of human cues, from facial expressions of opposing valence to attentional cues. They also communicate, they also learn from us and communicate with us. However, and also given the cross-modal recognition present in the conspecific context, I wanted to see whether they could recognize their next most important social partners, humans, using similar cross-modal cues. Before I go into how I investigated this, I wanted to just mention that all research was carried out in line with ISAE guidelines for use of animals research and was approved by a University of Roehampton Ethics Committee. My final sample size consisted of 28 goats, and I took photographs and voice samples from 10 familiar people. Photographs were used instead of live humans to prevent unintentional cueing of the goats, as well as other advantages. Playbacks consisted of 2 repeat voice samples of a familiar person saying, "Hey, look over here." It's followed by 10 seconds of silence in which goat responses were recorded. So each goat experienced 4 trials each, 2 congruent and 2 incongruent, using all face-voice combinations from 2 familiar gender-matched people. If we consider this example subject Donald, for his first trial, the face and voice both belong to the same person, so the cues could be said to be congruent. For his second trial, the face belonged to the blue person and the voice to the yellow person, so the cues were incongruent. This was the same case with the third trial, the face and voice from different people, and the fourth trial, the face and voice both belonged to the same person, the blue person, so the trial was congruent. Similar paradigms employed in cats and dogs suggest that goats, animals specifically attend to cues if they are incongruent, as this reflects a violation of their expectations. So, Goats initially entered my experimental arena through a prep pen where they were prepared for testing and were then trained to approach and investigate a target bucket. This bucket was directly in front of the photographic speaker during trials, so goats would be in an ideal position to experience stimuli presented. During an experiment, once the goat had approached and investigated the target bucket, the speaker was initiated and the voice playback. The speaker was hidden directly behind the photograph at approximately mouth level. Once the goat had listened to both playbacks and 30 seconds had passed, they were released from the arena. So on to what I found. Firstly, congruency had between the face, voice, human cues had little effect on the duration which goats looked or on the likelihood they looked. However, interestingly, it did, although goats tended to take longer to respond to playback 2 than playback 1, this was affected by the congruency between cues, specifically goats experiencing incongruent cues took longer to showed a greater increase in latency than goats who subject to congruent cues who showed a much more stable latency between playback 1 and 2. So to recap, congruency paradigms such as the one used here typically predict that animals will respond faster and for longer when cues are presented are incongruent, reflecting a violation of their expectations. Goats certainly did not behave as expected, and differences were only seen in one of the 4 response variables measured. So it cannot really be concluded with certainty, but the fact that they did change their behavior in response to congruency could maybe suggest that they had perceived the differences in congruency and could provide a first indication of how goats may recognize humans. Although not certain, it could suggest that cross-modal recognition could extend to a highly dissimilar, evolved in the initial conspecific context, could be applied to recognizing members of a highly dissimilar species, humans. So before I finished, I just wanted to quickly mention another study I ran as part of my PhD, goat discrimination of emotional valence in human voice. So typically emotion is often split using dimensional models, which typically split emotion into arousal, which concerns the intensity of the emotion experience. So from low arousal calm states to high arousal excited states, and also valence, which concerns where the emotion is positive. So for example, happiness to negative like depression, anger, and fear. Animals can use the emotions of others referentially to understand their behavioral motivations, and they could use these to adapt their behavior towards the emoter or the object the emoter is interacting with. Goats can distinguish interestingly, goats not only distinguish conspecific emotions, but they also seem to discriminate between human emotions as well. Specifically, they seem to show a preferential approach to humans showing happy, positive emotional facial expressions conveyed through a photograph rather than those experiencing negative facial expressions. And however, goats themselves have significantly less developed facial musculature, and although they do seem to discriminate goat facial expressions facially, the way in which emotion is conveyed across taxa is more dissimilar. So it might mean that vocalizations represent a more potent medium in which to discriminate heterospecific emotional cues. So what I presented goats with was a habituation, dishabituation, rehabilitation paradigm, the first phase of which, the habituation phase, comprised a series of 9 playbacks, all convey from a single speaker, all conveying a single emotional valence, in this case, angry, negative. And then once for the dishabituation phase, the emotion expressed changed, this case to dishabit to happiness. And if the goat had noticed this change in valence, they were expected to renew responses and increase responsiveness accordingly or dishabituate. And then for the third and final phase, the rehabilitation phase, the valence was shifted back in line with the habituation phase. So in this case, back to angry. So looking at what I found was that the probability of looking over the habituation phase significantly decreased, as did how long goats spent looking over the course of the habituation phase, suggesting that goats had habituated to the playback stimuli and had a lost interest. However, when the valence changed between the last playback of the habituation phase and the first playback of the dishabituation phase, goats continued to drop in their probability of looking, suggesting that these goats had not perceived this change in valence, or that they had got startled by the sudden change in valence. But this could not be confirmed. However, interestingly, goats that did look for longer, suggesting these goats at least may have saved this change in valence. So, in conducting this research, it provides the first evidence that goats discriminate cues present in the human voice, namely emotional valence. However, the ability to discriminate human emotion varied among goats tested. This suggests, potentially highlights the importance of individual level experience with human emotional cues in interspecific emotional communication. I just wanted to thank all my field assistants, my video coders, anyone that gave me useful advice from this experiment, my funders, the backup staff and volunteers, and of course the goats who took part in my experiments. Thank you for listening. Are there any questions?
So we open the floor to questions. Come here, please.
Sorry, thank you. I was wondering if goats' attention to humans would depend on the context. So if the humans were nearby but expressing emotion, it wouldn't be relevant to the goats unless they were being handled or maybe fed by the humans. Do you think it would depend on how close or interactive they were with humans?
It would, but this was like quite close by, just a loud voice presentation. I didn't want to, I wanted to just like keep it vocal cues, so I just isolated the voice, but it certainly could depend on how close the goat is, their experience of emotional cues with positive and negative events and this sort of thing.
Thank you for the question. Okay, thank you very much, and I think we'll leave it there. Thank you very much. So next up we have Rachel Kuhn, who's going to be telling us about measuring motivation for Sudan grass hay in cattle.
Okay, as Dr. Asher said, I'll be presenting my PhD work on measuring motivation for Sudan grass hay in finishing cattle using voluntary interaction with an aversive stimulus. So in the US, cattle are raised on pasture for beef and then moved to a feedlot for the last 150 days of life, where they're fed a finishing ration that's composed primarily of concentrates, which are otherwise known as grains. And this diet has an average proportion of forage between 8 and 10%, which is in stark contrast to the all forage diet that these animals have evolved to consume and would be consuming on pasture up until this point. And there are some consequences of such a high concentrate diet, those being that an increase in starch consumption can lead to an increase in acidity within the animal's rumen. And if that increase in acidity is prolonged and chronic over time, that can lead to subacute ruminal acidosis, otherwise known as SARA. And subacute ruminal acidosis has a few more severe symptoms, which I've listed here. Ruminitis, which is stomach ulcers, as well as liver abscesses, like the one in this photo, and systemic inflammation, which can lead to more acute signs such as a drop in intake and diarrhea. Alternatively, forages are thought to increase chewing, which ultimately can lead to an increase in saliva production, and that's thought to then buffer the rumen pH, or at least to neutralize the acidity within the rumen. So there is evidence in previous literature that animals are motivated to gain access to forage when fed a finishing diet. When experiencing acidosis, finishing cattle will sort for the forage or the long forage components in that diet. And in a study in which animals were given access to one of two treatments, they were either given access to a concentrate diet, as I've shown here with this icon, and then behind a weighted gate, they had access to forage. Or their second treatment were animals that had access to forage ad libitum, and then behind a weighted gate also had access to forage. The animals with access to the finishing ration approached that forage much more quickly than animals with access to the ad libitum forage. However, in that same study, the animals all pushed approximately the same amount of weight in order to access forage. And so that means that animals with access to forage ad libitum, who then pushed for more forage, were demonstrating contra-freeloading or working to gain access to something they already had freely available to them. So there are a few limitations of this study. First of all, contra-freeloading can complicate the interpretation of motivation for forage because it implies that there may be something rewarding about working to gain access to that forage. Secondly, the animals had to push an increasingly heavy gate in order to access forage, and that can also have a ceiling effect of strength. So the animals gave up very abruptly, and that indicates that perhaps they could no longer push the weighted gate, but it wasn't as though they were not more motivated for forage. And so in my PhD, I developed an alternative measure of motivation that used an aversive stimulus to avoid the possibility or to attempt to avoid the possibility that that task would be rewarding. And it also avoided the ceiling effect of physical strength. So at the UC Davis feedlot, finishing cattle have access to automated feed bins that measure intake and feeding behavior 24 hours a day. And so I outfitted these bins with an electrified barrier that hung in front of the bin and acted as an aversive stimulus. So here you can see a plywood barrier on which I applied an electrified surface. And then the two heat lamps above were added because we needed to avoid the possibility that atmospheric moisture would short the current on those gates. So the animal would push with their muzzles against the weighted, or not the weighted gate, the electrified gate, and that would then lead the gate to rise up and out of the way so that the animal could consume their diet. So here is a video of an animal using their muzzle in order to push against the gate, and then they lower their head into the feed bin. So they're not being shocked while they are accessing the feed. Okay, so using the Incintec bins and the electrified barrier, I aim to measure how motivated finishing cattle are to access Sudan grass hay using an electrified barrier as an aversive stimulus. All cattle had exclusive access to two feed bins, one of which had an electrified barrier hung in front of it, and the other bin had ad libitum access to a finishing ration. And all animals had 24-hour access to both of these bins. There were two treatments in my study. 14 animals had access to 0.2 kilograms of Sudan grass hay in their treatment bin, and then 13 animals had access to 2 kilograms of the finishing ration. So just more of the same of what they're already being fed ad libitum in the other bin. This is the schedule for how I increase the current sequentially over time. The animals had 48 hours access at which the current was turned off, and they could use the gate and access their treatment without being shocked. And then every 24 hours, I increased the current exponentially until the animals stopped accessing, at which point the current was shut off and the animal was considered to be removed from trial. For reference, 156 microamps, I cannot feel that with my hands when I push it against the gate. And currents above 3000 microamps are considered painful to humans. We also measured reticulorumen pH using a wireless bolus, and that gave us data over a 24-hour period continuously for all animals. I'm going to show you an example of what that data looked like for a single animal. On the x-axis is time over a 24-hour period, and on the y-axis is pH within their reticulorumen. These blue dots represent data for a single animal every 10 minutes over the course of that 24-hour period. The bolus is located in the reticulum, and so Sarah is diagnosed as a drop in pH below 5.8 for more than 3 hours per day. And what we found in this trial was that the majority of animals in our study were experiencing Sarah for at least 1 day while on trial. So I hypothesized that animals would be more motivated to access the Sudan grass hay than the finishing ration, and that they would demonstrate that motivation through a higher maximum price paid, so a higher current, as well as a higher probability of advancing to the next current level, and finally, a quicker time to approach. So first, I'll show you the results for maximum price paid, or the highest current these animals are willing to touch. On the x-axis is our 2 treatment groups, and on the y-axis is maximum price paid in current microamps. And as you can see, our results are unexpected. Animals with access to just more of the same finishing ration actually paid a higher price. So their mean current was 1,380 microamps versus animals in the Sudan grass treatment, which was 469 microamps. Next, I'll show you a Kaplan-Meier curve of the probability of advancing to the next current level. On the x-axis is current, and on the y-axis is the likelihood of moving on to the next current. Here you can see that animals with access to the finishing ration were more likely to advance. So in this graph, every step in the staircase represents an increase in current, and every drop in that staircase represents fewer animals that advanced to that next current level. And finally, I'll show you time to approach, as this is latency. On the x-axis is treatment, and on the y-axis is time to approach on the very last day that these animals access their treatment. So the highest current they were willing to approach at, and this is in minutes. And as you can see, animals with access to the finishing ration were much quicker to approach that diet than animals with access to the Sudan grass hay. During feeding, at the morning feeding, we locked them back so they could not access their bins until exactly 8 a.m. And then we measured latency from 8 a.m. onwards. So how do our results compare to previous literature? Well, first of all, we did not measure sorting behavior, so that doesn't apply. But we actually found that our research didn't align with that previous weighted gait study, and that our animals were motivated to access the finishing ration and were less motivated to access the forage. Secondly, when we look at the possibility of being motivated for forage from the perspective of maximum price paid, we find that the animals with access to forage had a lower maximum price paid. So why might that be? Why would animals be willing to access the finishing ration, which they already had freely available to them in an adjacent bin? First of all, you may have noticed that we fed 2 differing amounts in terms of weight of our 2 treatment groups. And the reason we did this was because we were replicating the weighted gait study, which used 200 grams of Sudan grass hay. And we also wanted to ensure that we were thinking very critically about the amount of feed we're providing as that reward each day. And so we matched them by volume instead. 200 grams of the finishing ration is a very small amount within a very large bin. And so we were not confident that the animals even knew there was something in there. So we matched it by volume instead. And so by matching it in volume, that means that the finishing ration was higher in calories. And from the perspective of optimal foraging theory, these animals may be more attracted to this diet because it is more calorically dense. And also, animals were fed the finishing ration ad libitum for 30 days prior to the start of the trial. So they were familiar with it. And the Sudan grass hay was only fed during that 48-hour period, making it novel. However, all the animals in our trial were experiencing Sarah on at least one of those days. So it is still surprising that these animals would be motivated to access something that could potentially be causing that. And that suggests that perhaps we didn't feed enough forage in order for the animals to experience the potential benefits of that additional roughage. And so in conclusion, animals were more motivated to access the finishing ration than the forage. And they were also more motivated to contra-freeload than we had previously considered. And so with that, I would like to thank the feedlot staff, as well as my interns and the grants that funded this project. Thank you.
So do we have any questions? Got one here. Just remember to stand up.
Hi, Rachel. Juan Darres out of Catholic University of Paraná, Brazil. What is your thought process to get to the shock instead of like other things? And then another quick question is like, did they have any experience eating hay alone, these animals? Or they were all TMR?
Okay, I'll answer the first question. So the animals had hay within the finishing ration, but it was a very small proportion. And then aside from that, they were access to pasture, which wouldn't have been hay, of course. So, no. And to answer your first question about why we chose to go with an aversive stimulus like electric current, we were trying to avoid especially the potential that they would contra-freeload, and that would be because there was something rewarding about that task. These animals are raised in fairly barren environments in which there is not a lot for them to do. There's cement flooring and it's a very small enclosure. And so we were looking for a task that would not have the potential physical ceiling effect of a weighted task or something that involved endurance. And we were also looking for something that would not be rewarding.
Thank you. We've got another question over here.
Hi, Rachel. Beth Montero, University of Lincoln in the UK. I just wanted to compliment you first on a beautiful talk. I thought here it was very clear and interesting. And I might just follow up a bit on Roland's question, because I think it's a really tricky one. But I'm especially interested in kind of the ceiling effect phenomenon, because the ceiling effect phenomenon of like having to push a gate, for me, that would be very aversive. Like I don't want to work out, like lift weights, but isn't there possibly a ceiling effect consideration with asking animals to kind of inflict pain on themselves? And could you talk a little bit about that, and then maybe some of the ethical questions about that as well? Thank you.
Yes, so this is the last in a series of trials. We ran pilot testing where we looked at the scale that we were increasing the current by and what our maximum currents would be. And we found that animals were reaching higher currents than what you observed in this study initially. And so we set our limits based on those maximums that were being reached in those studies. And then we refined our system, and that resulted in animals never reaching those higher currents ever again. And so we knew that at the higher currents, there was no physical damage being caused by that aversive current. And so we saw that as being a within humane limits to then have that scale applied. In terms of, could you have a ceiling effect of physical strength itself or of pain itself? Yes, but I think at some point we would start inflicting that physical damage that we did not observe at all in our trial. And then we actually saw that they gave up even below the currents that we had other animals going far beyond. And we also tried very hard to control for where and how the animals touch that current, because we know that if the animals were touching it with their hooves, for example, that experience would be very different than on their nose or on their muzzle, sorry. And so we made a lot of effort to ensure that no animal could press with their shoulder or push with the side of their face, for example. We wanted it to be uniform across all of the animals. So that included the surface area with which they're making contact with that barrier.
Thank you very much, Rachel. And I know there's loads more questions, but please could you just chat to Rachel so we can try and keep to time a little bit. Thanks. So our next speaker is online, I believe. So we have Sarah Capel, who's going to be talking to us about heart rate variability in horses during immediate and withheld food reward.
Hi everyone, I hope you can hear and see my screen okay. Just trying to get started. So I hope that works. So the reliable assessment of animal motion is a central goal in animal welfare science. However, it is often difficult to assess emotional valence, which relates to the pleasant or unpleasantness of an emotional state as compared to emotional arousal. And in addition, physiological indicators are predominantly used to measure negative and not positive emotional states. I'm Sarah, I'm a final year PhD student at the University of Plymouth in the UK, and I will be speaking about heart rate variability and eye temperature changes in horses during immediate and withheld food reward. The activity of the autonomic nervous system, or short ANS, is considered to be a valuable indicator of emotional state, as it allows the non-invasive measurement of real-time changes in emotion eliciting situations. And using proxies of the ANS, it is possible to measure emotional arousal. For example, using mean heart rate, where an increase in mean heart rate is reflected in an increase in arousal. Another option to measure emotional arousal is by measuring changes in surface temperatures, for example, in ice, using infrared tomography. And these ANS indices overall reflect activity of the parasympathetic and sympathetic nervous system, which are subdivisions of the ANS. ANS activity can also be related to emotional valence. For instance, changes in heart rate variability have been linked to the balance between the PNS and SNS activity, reflecting emotional arousal, valence, in humans as well as in animals. For example, or very broadly speaking, in positive emotional states, this balance of PNS and SNS is prevailed by parasympathetic nervous system activity, which regulates mainly rest and recuperation activities, whereas showing negative emotional states, there's a shift in this balance towards the sympathetic nervous system, which is the main coordinator of fight and flight responses. And the shift can either be due to an increase in SNS activity or through withdrawal of the PNS. And more recently, it has been suggested that possibly also asymmetries in bilaterally surface areas such as eyes might be linked to emotional valence. According to the emotional lateralization valence theory, which describes that during negative emotional processing, a higher activity in the right hemisphere is provoked, whereas during positive emotions, this increases activity or high activity in the left hemisphere. And this neurotheory suggests that this lateralized brain activity might be reflected in changes in surface temperatures in areas in the head that are closely located near the brain, for example, the eyes. And our aim was to test indices of HRV and ERT during positively and less positively valence situation in horses. And for this, we tested 32 animals from 2 different facilities. And these animals were previously conditioned to contact a target object with their muscle for food reward. And we exposed them to 2 conditions, either an immediate reward condition where the horse, sorry, something is not working here. In the immediate reward condition, the horse would perform this conditioned response like so. It was presented with the target object and would receive immediately a food reward. And in the second condition, the withheld reward condition, the horse would be asked to perform the same conditioned response like so, but here no food reward was given. Other than that, the behavior pattern was exactly the same. We split the horses into groups in order to apply 2 different reward schedules, like indicated here. And we did so in order to control for time effects associated with physiological changes in response to food reward. And horses were tested in 2 × 10 trials per session. And from these 2 sessions, we extracted 5-minute ECG recordings, as well as 6 thermal images, where we then extracted the maximum eye temperature of the inner corner of the eye. Coming to the results, so indices linked to emotional arousal. We predicted that, for instance, mean heart rate would increase in both conditions during immediate and without reward, as an overall increase in arousal without any significant difference between those test phases. And that's exactly what we found. So confirming our predictions. In terms of maximum eye temperature, here we expected that there would be a drop in maximum eye temperature during both reward conditions due to SNS-mediated vasoconstrictions in peripheral areas, including the inner corner of the eye. We split our data set into the 2 different facilities, and we found there was a significant drop in both conditions at yard 1. However, there was only a significant drop in eye temperature at the 2nd yard during immediate reward, but not with the withheld reward phase. We furthermore found a somewhat unexpected finding. There was a significant effect of handler position, with maximum eye temperature being higher, considered in the eye, and that was the same side as the side the handler was standing on. And this was a significant fact that we found at both yards again. In terms of SSD and high frequency HRV indices, these are indices that are predominantly reflecting PNS activity. And here we predicted that in both reward phases, there should be significantly differences in the direction of these values. I hope you can still hear me because I'm getting a message that my internet connection is unstable, but I'll carry on. However, we found no significant changes in arm SSD and high frequency values. We furthermore analyzed SDNN and low frequency, high frequency values. These are heart rate variability indices that reflect the combined effect of PNS and SNS, in particular low frequency and high frequency ratio related to the balance between the 2 systems. And again, we expected significant differences during the 2 reward phases. However, we found an overall increase in both types of values, with a significant increase during both reward phases in the low frequency, high frequency ratio values, and a significant increase from baseline during the immediate reward phase for SDNN. And so overall here, our predictions were only partially supported. And this change in heart rate variability indices overall suggests that there was no change in PNS modulation, but an increase in SNS stimulation on cardiac activity. And lastly, in terms of the asymmetric eye temperatures that we investigated, so here we looked at a left to right eye temperature difference. We had no directional prediction, as there are multiple reasons how bilateralized brain activity could result to changes in overall surface temperature, which I'm happy to explain more in the discussion. Overall, we found that in yard 1, there was no significant difference in asymmetry temperature profiles in the eyes. However, at the 2nd yard, we found there were significantly differences between the withheld and the immediate reward phases, with a higher left than right eye temperatures in the withheld reward phase, and the sort of opposite temperature profile for the immediate reward phase. However, these results need to be considered carefully because in comparison to baseline, there was no significant differences. But overall, these findings encourage further investigation that asymmetric temperature changes might be associated to emotional valence. But to conclude, so we found that both immediate and withheld reward related to changes in HRV and ERT indices associated with emotional arousal. However, reward or immediate reward. So we kind of questions whether our reward value was not high enough to balance towards a more positive state, and likewise maybe withholding the reward was not punishing in that sense. So these horses were previously trained to touch the object for food reward in a different study, so they've already performed quite a number of trials, and hence there might have been some sort of automated response that they were performing. So using a more complex task might lead to very different emotional temperature profiles. However, our results do show that external factors are important to consider when investigating physiological profiles, in particular handler effects, as well as effects of ambient temperature. The latter might have also influenced our the effect of left to right eye temperature difference significantly higher. So it's possible that we've seen some ceiling effects here. So overall, we need further validation that we can use asymmetric temperature profiles as a proxy of emotional valence. But overall, our findings encouraged the assessment of further changes in HRV and ERT values in association of positive emotionless. Any questions?
Thank you so much, Sarah. And just to let you know, your internet more or less held up. There were just a few.
Okay, great.
Thought we caught nearly everything. So thank you so much.
Sorry about that.
No, not at all. Well done. So do we have questions? There's a question here, back, please. Can we go there first? Yeah.
Thank you. Peter Nielsen, U4. You found some lateralization based on your treatment or your test, but you also found the handler effect.
Mm-hmm.
It gave reason to different sides. Were you able to disentangle that?
Yes, sorry, I should have said we controlled for a handler effect or for handler position. So in each trial set, so the horse were performing 10 trials per set, we switched the handler position. So this would not explain our finding. Yeah.
Yeah, Jan Langman, Dummelsdorf. Question regarding the change in the ratio of the high frequency, low frequency, or other way around. So in the IR condition, you find in the IR condition, you find a change in the ratio towards a stronger sympathetic activation. How do you explain this?
So we had an overall increase in both phases without kind of like significant difference between reward phases. And overall, I would suggest that it's kind of like as a reflection of arousal. So hence maybe just increase in SNS activity. But yeah, I'm not, if we would have expected an increase in kind of like PNS activity, we would have actually expected a drop in these kind of values, which we did not see. So, I mean, overall, yeah, the fact that, so one thing that I did not mention as well was horses continued performing touching the object, even though they were not rewarded. So, which I think overall might suggest that they were maybe just kind of like in that kind of mindset of this was a previously task that we've learned to do. So it was maybe just kind of more an automatic response.
Thank you so much. It's a lovely presentation. And just could we thank all the speakers from the session today? We've got some more. So before you rush off, we have the very quick, fast-paced poster presentations, and we've got 10 of those to get through. So could I have all my speakers line up here behind the stage, if that's okay? Okay, so first up we have Sarah.
Hello, I'm Sara Juntila from the University of Helsinki. Have you ever wondered which dog breed is the most intelligent? Our study shows that the answer depends a lot on what we define intelligence as. We compared the results of 13 dog breeds in 7 cognitive tests, which measure different aspects of cognition, such as inhibitory control, social cognition, memory, problem solving, and logical reasoning. If you're interested in finding out what the results were, come and see my poster tomorrow, number 79. Thank you. Luba?
Hello, I'm Lubor Košťal from Center of Biosciences in Slovakia. Radio mazes are used for decades for studying spatial learning and cognition and then memory in rodents, but they are not that frequently used in birds or in chickens. And that's why we wanted to look at that, design and develop this system, as you can see. And we compared the performance of laying hens kept in deep litter and on enriched cages. And if you want to learn more, come to poster number 80.
Katerina?
Good afternoon. My name is Katarina Pichova. I'm from the same institution from Slovakia as the speaker before. Well, as you can see in the title, this poster is about the optimizing the judgment bias in laying hens. Yesterday, we heard that is one of the modern methods for assessing animal emotional state and also different aspects of animal welfare. Of course, it's not ideal. So if you want to see how does it work in our experiments, or if you want to share your experiences, please come to the poster number 81. I'll be thankful. Thanks.
Isabel?
Yes, living together isn't always easy. You may relate to that. I can, I'm married. I have experience in it. I'm Lisbeth, I'm a PhD student at the Ghent University and at the ILVO, which is a Belgian research institute. And I try to research the group housing of female breeding rabbits in the meat rabbit industry. And I think we can agree that rabbits are social animals, but the problem is that these rabbits are housed individually on these Belgian meat rabbit farms. And by housing them in group, we hope to allow them for more space and for more social contact. But that social contact sometimes goes very ugly, and skin injuries and stress are not unlikely to occur. So by trying enrichment, we try to deal with these negative consequences. If you want to know more or you're totally hooked on this subject, please come visit me at poster 82, the big white rabbit. Thank you.
So I think we should have Courtney next. This is Logan. I had Courtney. No. Okay, so we'll move on to the next poster, if that's okay.
Yes. So my name is Claes Andersson from the Swedish University of Agricultural Sciences. And poster 84 is about a study where we collected a lot of behavioral data from 4 individuals, each from 5 different feline species in zoos. The work is under progress. We're analyzing the data. It's risky business looking at different species as a whole, but we're hoping that this may shed some light and give some information about behavioral responses that could be associated with, say, enclosure designs or management routines that would be of interest to the zoos housing these species. Thank you.
So much.
Beth? Hello, everyone. Beth Ventura, University of Lincoln in the UK.
So this is a little bit of a different project than most of the talks, although we heard some wonderful presentations earlier this morning in the social science area. And so this is a project where, in addition to being interested in what animals do and how they think, I'm also interested in what the people who work with them do and how they think, and how we can together get diverse stakeholders communicating a bit more productively so that we can then go ahead and implement changes on farm or in other sectors a little bit more productively. So for this particular project, we asked people what they think. I do this a lot. And so for this project, it was wanting to know what some key stakeholders in the cattle industries, specifically veterinarians and animal scientists, what they think about how we should be moving the cattle industries forward, specifically how and should we integrate the general public into these conversations. So these nice colorful graphics illustrate some of our results, which I now see are too small for you to read. So if you'd like to discuss this with me in person, I will be hanging out at poster 85. Thank you.
Well, I understand our next 3 posters are going to be online presentations. So first up, we've got Annika.
Yeah, hello, can you hear me?
We can.
Yeah, great. Hi, everyone. My name is Annika, and I'm working at the Research Institute for Farm Animal Biology in Dummersdorf in Germany. Unfortunately, I cannot be there, but I'm very happy to present online my poster about emotional contagion in domestic pigs. Do you feel what I feel? So our main aim was to investigate behavioral and autonomic responses of pigs that might be linked to the transmission of emotions. And we tried to answer following questions. First, do naive pigs show emotional contagion in the context of a demonstrator-observer paradigm? And second, if yes, what are the influencing factors? So is emotional contagion stronger in negative contexts compared to neutral or positive situations? And how does previous experience with a situation may affect emotional contagion? So to find out more, please visit my poster number 86 online. Thank you and have a great day.
Thank you, Annika. And then we have Miho up next. Miho's video.
Hi.
I think Miho's on.
Can you hear me? Hello, can you hear me?
We can.
Sorry. Hi, I'm Miho Saito from Japan, and our presentation is about how the presence of a male giraffe influenced the frequencies of social interactions between female giraffes. So our aim was to understand the effect of male presence on female giraffe stress levels. So we investigated FGCM levels and also social interactions in 2 captive female giraffes. Then we found that there was no significant difference in the FGCM levels in females between the conditions of the male absent or present. However, the frequencies of aggressive interactions from the dominant females to the subordinate female was significantly increased when the male was present. That's all. Thank you very much.
Thank you so much. And our very last poster is Rosalina. This might be a video. In one of these files. Oh, no, we have Rosalina. We're getting there.
Hi, my name is Razlina Rakhazli and I'm from the Department of Veterinary Services Malaysia. My poster presentation titled Public Knowledge of the Legislation, Awareness and Attitudes Towards Animal Welfare, a study among clients of the Department of Veterinary Services Malaysia. This study focused on the effectiveness of the promotional activities held by DVS since 2012. There are 3 parts of the questionnaire, which are number 1, the demographic data, 2, awareness of the current animal welfare legislation, and 3, general attitudes of the public to the current animal welfare issue in Malaysia. In conclusion, 80% of the total 200 respondents in this study were aware of the current animal legislation and 90% of them were aware of the basic needs of the animals. About 22% of the respondents who live in urban areas think there are insufficient animal welfare promotions in the country. Most respondents think that the stray population is the main issue of animal welfare in Malaysia, which shows that they only focus on pet welfare. The DVS can use data from these findings to expand and diversify the promotional activities of animal welfare to the public.
All right, so brilliant. Well, that wraps up this session on motivation, cognition, and emotion. And thanks to everyone for sticking with the session. Thanks to all our speakers and our poster presenters, and especially to those online who have managed to engage despite not maybe having to see the audience, etc. So thanks to everyone for being here.
So don't run away, everyone. We have got a workshop, or it's actually more of a presentation about one of our the organisations we're working closely with. So please don't go too far. You won't find any coffee, I don't think. So I went looking for it. So if you're in search of caffeine, unfortunately you're not going to find any. So please do stay with us, some of you, and we'll have a presentation in a couple of minutes.